Hello, this is meant to be a very quick review before you start Lab 2. If any of this material is unfamiliar, you need to go back to ZY Books or to the lectures. So here we have an example of fprintf. So we have our variable ti, which we set to be 22, and our fprintf format looks like this. This is the fprintf command. These little tick marks say that this is a string, and you'll notice this is colored purple, which indicates it's a string. This part of the text is pretty much printed as is, and this is the fancy little bit that says go grab the value of this number at the end and put it in here. This number is how many spaces to use total, and this number is how many decimal places. So right now we're asking for no decimal places. And this magic \n says make a new line. So when we print this, we see the atomic number of titanium is 22. So it took the value of Ti and put it in here. So if we leave out the \n, this is what we get. You'll notice that it didn't start a new line. And if we print out the same fprintf statement and we do something like this, then you'll see that we've now printed out 22 with 2 decimal places, and it's taking up 2 spaces. So next thing we want to look at is array creation. So this week is all about arrays, and there's a bunch of different ways to create arrays. So I'm going to walk through some of them. So this is probably the most common one that you'll see, which is linspace. So this says give me a variable that starts at 1, goes through 10, and has 100 elements. So if we print it out, we'll see that x1 got made, and instead of having a number here, it says 1 by 100 double. So that means it made 100 numbers. If we click on x1, we can actually see what the values of x are. So you'll notice there are 100 values in here, and they go from 1 to 10. And when I talk about arrays, so x1 is the variable that has this array. This is what index is in here. So when I talk about the 4th element of x, I'm talking about this. So if we close this out, actually I'll leave it up. So if we do x1 of 4, we get 1.2727, which is the 4th element of x. There are a couple other ways to make arrays. You can make it using the colon operator. So this says start at 2, step by 0.2, and end at 5. And those are the numbers you get back out. So you start at 2, you step by 0.2, you end at 5. You can also count backwards. In this case, we need to make sure that we actually, if we're going to count backwards, this needs to be a negative number. We're going to start at 5 and count down to 2. Same thing. So that's another common way to make arrays. You don't have to do the step, it defaults to 1. So if I do y is equal to 1 colon 5, it will make 1, 2, 3, 4, 5 with a step size of 1. Other common ways to make arrays are zeros. So this is the number of rows and number of columns. So this makes an array that has 1 row and 5 columns. If you forget to put the 1 comma in, it will think that you wanted something that's a 5 by 5. So if this happens to you, remember to go back and put this in. There's also a ones command that you can use to make an array of ones. And you can always do things like this if you want to make an array of, say, 4s instead. Let's talk a little bit about plotting. So if you want to plot, you need an array of x values and an array of y values. So here I'm going to cut and paste these. So this is, I'm going to make an array called xplot that starts at 0, goes to 3, and has 100 elements. I'm going to create another array from that called yplot, and you'll notice xplot shows up in here, and you'll notice all these dot times, dot hats, and so on. These are element-wise operations. So it says take every element of x and do this calculation with it. So let's do that real quick. So you notice now we have an xplot with 1 by 100, a yplot with 1 by 100 as well. So let's see what this looks like. It's a little bit big to try to print out to the screen, so we're going to plot it instead. So this is a straightforward plot command. It says here's the x values, here's the y values. These two arrays have to be the same size. If you create them like this will happen automatically. This says I want to make a dashed line that is colored red. So when we do that, we get a figure, and here's our figure. It's a little hard to see, so it starts at 0, goes to 3, and then these are our y values here. Now it's hard to tell what's going on right here because there is no label on this plot. So let's add some labels. We can add x labels, we can add y labels. So there's our x labels and our y labels. So now we have labels. We can also plot something else in the plot too if we want. So I'm going to create a variable called y2, and it's going to have make a little flat line here. I'm going to plot x, I'm going to plot y. This thing here, hold on, says plot over the top of the other one. So if I just do this, I get that blue line plotted here at the value of 50. And there's the y value of plot that I had before. If I do not have hold on, so if I do CLF, clear the figure, so now I have nothing in here. If I do, I'm going to go back over here, I'm going to replot my original plot like that. There we go, that one. So if I do that plot, you'll notice that the red one went away. So unless I do hold on, it'll just keep overwriting the one. So hold on says keep the last thing that you drew in place. So a couple other things. You can do legends and titles as well. So here's that red plot, here's that blue plot. Here's our X label, here's our Y label, and this is the legend. The only tricky thing about the legend is that it has to come after you do all of your plots, and you'll notice that its format looks like this. So we have one string for that first plot, and we have one string for that second plot. So you have to do string, comma, string, comma, string for however many things you want to have in the plot. That's it. Go ahead and get started on the lab.